Good afternoon, everyone. This is Track Man 44. Now today, what we're going to do is we're going to continue on with that makeover of this old rusty wood furnace that's been laying out in the woods for a long time, because we're going to use this for temporary heat in the shop while I'm redoing the boiler that's actually going to heat the floor, circulate hot water through the floor. For now, we're going to get this forced air furnace back in operating mode. But what we're going to do today, we're going to go ahead and temporarily install a flue pipe. Let me stress temporary. Temporary means not permanent. Temporary in some cases means some things that is not really recommended. Like for instance, I'm going to use some galvanized flue pipe simply because I've got some. This is a wide open area. It's going to dissipate any galvalume or whatever the galvanic fumes are that's given off from a galvanized pipe whenever it's heated. It's not going to bother me this little bit. I got the doors open and stuff anyway, while we burn everything off. So let's take a look at this right here. Calling this Class A 2100 degree stainless steel fully insulated flue. It's good for a 1 hour chimney fire at 2100 degrees before it'll do any deterioration whatsoever. But you want to convert that big thick insulated pipe down to the size of flue pipe that you've got. Of course, I'm putting the 6-inch adapter that goes from the outside dimension of the stainless steel Class A chimney down to the black pipe that's going to go down to the stove. This adapter came prepared for it to be inverted, or for the pipe to go with the wrinkles towards the furnace instead of the wrinkles towards the flue pipe. Okay, and like I said, the flue, sometimes they recommend that you go backwards so that the liquid creosote will go down. So enter this little adapter right here. Now what this does, this takes that inverted adapter, or adapter from the 2100 degree flue down to the 6-inch pipe. Because it has wrinkles pointing down, it allows you to put a female portion on that, but yet end up with a female portion on the other end as well as a male portion. This particular fitting right here allows you to install this in such a fashion as to where you have a standard way of installing. Now, my flue gases goes up on the inside, and it can't come out and run down this way simply because it's between the male and the female adapter on the inside. So this pipe actually goes in between the two surfaces of this. So any creosote that develops up here will drip down here and still go on the inside of this piece of pipe right here. But I don't intend on that being a problem because I'm not going to burn it in a situation that's going to develop creosote. I have exceptionally dry wood, and I'm going to burn it hot enough where I don't have to worry about that. So we're getting ready to install this part right now and start coming down with our temporary flue. Hopefully that made a little sense to you. Put 3 screws in every flue pipe. Here's one here, and one here. Try to get your 3 screws approximately 120 degrees apart. In the event of a volatile flue fire, you cannot believe what happens to these flue pipes. They'll move back and forth. The volatility of them is just beyond understanding unless you've experienced one. And with the triangulation or 3 different screws, the flue pipe itself will remain rigid. If you just put 2 of them in haphazard, especially across from each other or just even partially across from each other, that flue will actually move back and forth with the volatility of that explosive flue fire, and it could actually come apart and give you somewhat of an issue, give you a real bad day. So generally speaking, always 3 screws 120 degrees apart. But normally what I would do is this would set just a few inches behind the furnace, and this would drop straight down to the point at which it enters into the back of the furnace, right here. This would be right over here, the length of a 6-inch radius, or roughly 9 inches on center from the center line of the flue drop, and then that would go into a clean-out T. In other words, it would be a T fitting with a clean-out plug in the bottom, so you can pull the plug out and then clean anything that you might need, in a straight shot right up the chimney. But because this is temporary, what I'm going to do is I'm going to put some kind of an angle, hopefully somewhere 45 or something like that, from here right over there, and then 45 up, no clean out. Again, this is temporary because this is going to be here just while I'm working on the boiler. The boiler actually is going to set over there, so I don't want to be anywhere in the way of working on the boiler. Now typically if you take a 4-way adjustable 90, and again, this is hot air pipe, this is not flue pipe, so do not do what I'm doing. But typically if you take a 4-piece adjustable 90 and adjust one of the pieces, one of the end pieces, either that one or this one, okay, twist it around 180 degrees from start, that's going to give you roughly a 45 degree. It's a nominal 45 degrees, okay? You can just double check that by putting your square down there. It's roughly 45 degrees. Now remember how I said some of the furnaces suggest, or some furnace manufacturers suggest, that you run the flue pipe upside down as compared to a forced air. This one here, I'm going to start off with it that direction, but I'm going to change midstream and go and reverse it and go inside the joints. So when that is the situation like it is right now, because I'm ready at this next section of pipe to make that change, you have to have you a set of these fancy little guys right here. They're just hand crimpers. I've got crank style, but I've done many of them on the job, you know, just with these guys right here. And what we'll do is we will create those wrinkles on the other end, or those crimps on the other end, so that now we'll have a male end on both ends of the piece of pipe. So we'll be able to enter it via a male end and exit it the same way. I might just go ahead and go over to the other shop and pull out my bench mounted one and show you guys how to do it with an actual mechanical machine. But if you notice, there's 3 fingers on one side and 2 on the other. You can use them either way, put 2 on the outside or 3 on the outside, doesn't matter. But at any rate, you don't have the bead when you do it like this right here, and it's not quite as deep because the depth of those crimpers are not quite the same, but you still end up with a workable male end now on both ends of the pipe. Pretty cool, huh? Just to illustrate the mechanical way of putting those on there. Now if this was a round piece of pipe, you would just be rotating the piece of pipe around with your left hand. See how nice and neatly that duplicates the factory? And of course if I tighten it just a little bit tighter, it'll run those wrinkles closer up to the bead. But I don't necessarily want to do that. What happens, the tighter you do it, the more it'll put a radius on it and then make the diameter, the inside diameter of the pipe smaller and smaller. But I'll illustrate that by turning it just a little tighter now. It changed the radius so much, it took that flat piece of metal and completely curved it. So at any rate, that's another option for doing it other than the hand operated crimpers. Actually, that's going a lot easier than what I thought. Now, I do want to stress too that it's definitely not recommended really to use these adjustable 90s. I think you can use the 26 gauge and 24 gauge black 90s, but definitely not the galvanized, simply because, remember I described the volatility of a flue fire if you're unfortunate enough to have one. I think they pretty much recommend this type of non-adjustable 90 or non-adjustable 45 in that particular case. And the reason being, you don't have all these joints right here. Those 3 joints are just kind of a groove joint, a male and female groove joint that allows it to slip and slide and become adjustable. These guys here are not adjustable. And in the event of a flue fire, they're not going to break apart. These could possibly break apart. Now what I've done, I've made a bit of a rolling offset because this has to set a little farther out from the wall than what the boiler is going to. So I've made a rolling offset, and so this is not perfectly in line with this because of that offset. I had to do that to make alignment. But eventually when the boiler is set in place, it'll be straight out the front and straight up. So we'll put a few screws in here. Again, it doesn't have to be 120 degrees apart, but it's definitely suggested to be so. I like to get one right in line with that joint, simply because if there is a flue fire, that'll assure that that joint won't pop apart. Three in every joint. So now I'm going to put one in the bottom. I'm going to drill that real gentle so I don't shear the screw off in that thicker furnace material. So there you have it. Temporary flue pipe on a temporary wood-fired forced air furnace, going straight up to a Class A 2100 degree stainless steel inside, stainless steel outside, insulated flue. Class A chimney. Next step is I'm going to take a couple of these 10-inch 90s that are just salvaged off a job. I probably had them up above the other shed for probably 20 years, 25 years or so. But I'm going to be placing these 90s on top of here. I might make loose connections here to where I can actually shift them. If I'm working towards the front of the shed, I might want to rotate them this way, you know, or if I'm working on the other side of the shed like that, I'll be able to rotate them and push over that direction. But that's going to be a permanent installation on the temporary installation, so to speak. And when you're ready to cut your holes, you have to think about or consider what that heat exchanger looks like in here. A lot of times it's just a square box. This particular one comes up and it 45s over, or it angles over, and it has somewhat of a pointed top right here dead center. Okay, if you think about it, if you cut a hole back in this corner, how are you going to get a mixture of air from the surrounding area of the heat exchanger if you cut along this side or on that side of that center point? You're going to get the majority of your air off that heat exchanger coming up from back here in the back end and that one side. So I would have a tendency to believe you'd want to put them towards the center. Now bear in mind, this is temporary. Ultimately this will be become installed somewhere or another with ductwork attached to it. So I'm going to put these in the center for two reasons. First, because that way I believe I'll get a mixture of air from both sides of the heat exchanger like that. Plus, I'll be able to easily adapt those two round holes into a rectangular opening for whenever I want to add a flanged fitting for a plenum and then ductwork coming off of it. So you have to determine what size your holes need to be. I always use a wooden ruler because the spikes on your trammel points or on your dividers actually bite into the wood. If you have it on your metal tape measure, they'll slip and slide and you're going to miss by 1/16 or 1/8 of an inch. So you just set this up here, divide whatever your dimension is by half to get your radius. Is that necessary to have them centered? I don't know if it is or not. You're going to get heat out of it. It's just that I feel that there's going to be a more balanced amount of heat if you make sure you get a combined airflow off of both sides. I take an old screwdriver that's no good anymore. I'll just grind it down to somewhat of an angle, and then in addition to that, I'll grind the sides just a little bit to give a little bit of a knife edge. So now I've got that angle and that knife edge at the bottom of the angle. Now, this is not light material. This is 22 gauge material. 22 gauge is a lot thicker than your standard residential ductwork. Standard residential ductwork is going to be 28 gauge and in some cases 26 gauge. So this is going to be a bit of a bear to knock a hole in and a bit of a bear to cut. Like I said, bear in mind this is 22 gauge. And I'm standing on a milk carton or milk crate. That 22 gauge has got some metal in it. So it's time to give our attention to putting notches in the 90s. Now, do you remember my 30-degree V-notchers that I highlighted in another video? I think it was on a bird feeder that was a squirrel guard. Bear in mind, you're going to be bending these tabs over, you know, with your fingers. So the thicker the material on the fitting, the smaller you want those 30-degree V-notches. This here is it's a pretty tough material. Fingers are going to get tired by the time I get them all bent over. But we're going to take and put a select few and bend them to the outside so that the fitting will not fall down inside the plenum opening. And then we'll stick the rest of them down inside This one here is the double, so I'm not going to bend it over more than likely. But we'll stick those down inside and then bend them over from the inside, holding everything together. I just saw a note embossed in the side of that. This is a 24 gauge. That's why I'm having a little bit of a tough time popping all of those. To put that in perspective, the holes in the top I just cut is in 22 gauge material. The sides I put on in 26 gauge material, and these are 24 gauge 90s. So we got a pretty good variety of material. Now, like I said, I'll bend about every fifth one, bend about every fifth or sixth one out, and then drop the rest of them down the inside, stick my hand inside, bend them over to hold them into place. And I told you I wasn't going to make them real tight simply because this is a big area. It's 1,200 square feet, and I want to be able to grab a hold of them and kind of shift them if I'm working back in this corner, or if I'm working up that direction up there. I want to be able to shift them fairly easily to where I could just divert air the direction that I want. So at any rate, yeah, we got a fire going in it, burning the chimney out right now. It's smoking pretty good. It's going to get to a nice hot temperature here before too long. And in the meantime, I'm enjoying just a little bit of warmth. I got this old thermometer. Now this thing is an antique, man. I mean, I've had it hanging in my old shop for 35 years or so. It's a bit remote sensing bulb. I would think, if I remember right, that's about a 12-foot sensing bulb on it. And it's made to go into a well, half-inch pipe fitting, and it goes in a well, and it's actually supposed to sense water temperature passing across that, and then you can read it over here. But you know, this is going to be good enough for me here. I'm going to just hang it in front of here and just kind of get a rough idea of what temperature my area is coming off. And if you notice, I got me a temporary squirrel cage blower off of a gas-fired furnace, but I've got a multiple speed switch right here, and it's actually a 4-speed blower motor, and I'm running it on low because the higher the velocity, the lower the temperature feels. Let's show them our furnace. What do you think? Obviously, we've got the blower mounted on the back. I got some old wet wood sitting in front of the blower, just kind of sucking air across to dry them out. And you can see, of course, the flue pipe going up there in the back by the ladders. Got my 10-inch round runs off the top, and I've got a fire in it. You can see inside she's going pretty good. I've got the bypass damper in a closed position because we're definitely in a secondary burn. I've got the ash door currently open right now because I don't have a combustion air fan yet, but I can modulate very easily the temperature that I want by adjusting this door, you know, actually closing it or cracking it or whatever. And take a look at our discharge air temperature. Right now we're currently setting at about 118 degrees. So yeah, if I leave that door open for about another 10 or 12 minutes, it'll be approaching 135, 138. And that is definitely some heat coming into the space. Whenever you first light off the fire chiefs, you pull this all the way out, and that opens up a bypass damper to allow it to draw directly up the flue in the back to get your fire going really quickly. And then you close that, and then that puts it through that secondary burn chamber. So yeah, all in all, it's doing real well. One thing I forgot to tell you, when I pieced together an old blower, I had a multi-speed blower. I think it's a 4-speed that I've got a 4-speed switch on it actually. But you can get a little fancy with these things here. You can put on a thermal sensing switch that'll actually change speeds. The hotter the fire gets, the higher you can actually run that blower. And what it is just simply a 2-position switch. When it clicks the first time, it'll close the circuit to the lower speed, and as it gets hotter and hotter, it'll flip the switch again, and it will take out the lower speed and simultaneously energize one of the other higher speeds that you so choose to pick. So I could always go that route because, you know, wood, depending on the type of wood and how dry the wood is, you can have different, you get such a variance in the discharge air temperature on that particular, on a fire. So by making that provision, you can automatically increase the speed, which will move more heat across the heat exchanger and keep it from achieving a over temperature condition by simply switching it at a higher temperature into a higher cubic footage of air per minute air delivery. Normal fossil fuel furnaces like natural gas furnaces, propane fired furnaces, and oil fired furnaces operate off of roughly a 70-degree temperature rise. If you take a look right here, you can see 140, 150, so about 146 degrees, 146, 148 degree temperature, discharge temperature coming right off of this. So when I talk about temperaturized is the amount of temperature that the air, when it comes in the return, as it passes across the heat exchanger of your furnace, that it rises to when it comes out the top of your furnace. Now if you stop and think of your house is roughly 70, 72 degrees, typical return air temperature, or typical space temperature, and if you consider you're returning 70 degree return air through the ductwork to your fossil fuel furnace, you should expect to get roughly 140 degree discharge air temperature. So what I'm doing by showing you what I've got running right now, about 146 or 148 degrees, that's well within the norms of what you should be able to expect out of a wood-fired furnace. It's not unsafe, not dangerous, nothing like that. But if you do allow it to get too hot is roughly the 200 degree range, you should have the means in the control circuit to where when it exceeds that temperature, that you cut the power to what provides combustion air to the fire, be that a damper or be that a combustion air motor. So that's just a little safety tip for y'all. But it's Cadillacing right exactly where it needs to be Cadillacing. It's not that cold outside. It's only about, I don't know, 22 degree Fahrenheit. So it's not all that cold, but it does feel good in here. So as far as temporary heat goes in my shop, you know, this pretty much draws this one to a close, because except for putting a control on the fan and actually physically attaching the fan, I'm pretty much done with it. I'm not going to spend a lot of time doing a lot of extra things to it, simply because this is only temporary, because I've got another project in the works that's going to provide heat for the floor of this particular building. But at any rate, this is just another one of them projects that goes to show that, you know, you can, if you keep your eyes open, you can come up with stuff, you know, that doesn't cost you a whole lot and doesn't cost a whole lot to put back in service, and it's much to your benefit. So that's about all I got to say. This Tractor Man 44, and I am out of here.